All right. Now this time we have a question where I'm asking you to first verify that the differential equation is exact. And then after verifying, you have to solve. So actually the question is asking for two parts. If you forget to do the first one or the second one, you don't get the full credit, okay? Let's solve it. First, how do you solve for exactness? Whenever you solve these exact differential equations, the first thing that you have to keep in mind is the thing that's in front of dx is f sub x, and the second one in front of dy, that's f sub y. If you know that this is fx and that's fy, then everything else just falls into their places. So it's very important that you never forget these two things. That this you should think of it as f of x, and this one you should think of it as f of y. Okay? Now, first, the test for exactness. Well, how do we test for exactness? We use the property that the second partials commute, and fxy should be same as fyx, right? How do you apply this? Well, this is already f of x, so in order to get fxy, you should take f of x and differentiate by y. That's what you want to do. Which means you have to differentiate the first one, 3x cosine y, cosine y, plus 5 with respect to y. Now this is a partial differentiation, which means you're considering x as a constant. So although you have 3x is not a function, you have to consider this as a constant multiple of cosine y. So only thing that you have to differentiate is cosine y. What do you get if you differentiate cosine y by y? Negative sine y, right? So you get negative 3x sine y, and if you differentiate 5, that's equal to 0 because it's constant. Constants always differentiate to 0. So that's what you get as fxy. Let's think about fyx. Fyx is you take fy and differentiate by x. Okay, this just means you take fy and you're doing another derivative with respect to x. That's what this means. And since we decided that f of y is negative 3 over 2x squared sine y plus 3y squared, we take this fy and we're going to differentiate by x. When you differentiate by x, now this time the y's are considered as constant, so although this looks very scary, it's just a constant multiple. The only thing they have to concentrate is what's the derivative of x squared? What's the derivative of x squared? 2x. That 2 cancels with this 2 down here, so you end up with negative 3x. It becomes negative 3x sine y. What about this one? What do you get if you differentiate 3y squared? 0, right? 3y squared is considered as a constant when you differentiate by x, therefore you get 0. Now, are they equal?
Yes.
Yeah. So check. They are exact. Okay? So we do see that it's exact. Now let's attempt to find our f. The function f, therefore, should be taking the integral of what we perceive as f of x. We should integrate by dx. Once again, cosine y is considered as a constant, so when you integrate this, the only thing that you have to focus on is x. Integrating x gives you 1/2 x squared, so it's 3 over 2x squared cosine y plus 5 if you integrate is 5x. And then it could possibly have a function of y because we're integrating by dx. All right, next, we take negative 3 over 2x squared sine y plus 3y squared. This time, because this is f of y, to undo it, I'm going to integrate by y. And that gives us 3x squared, 3 over 2x squared cosine y again, because if you integrate sine y, it's cosine y. however scary this looks, it's just a constant multiple, so we don't care. We are only integrating sine y to give you cosine y. 3y squared, if you integrate by y, you get y cubed, right? If you differentiate y cubed, you get 3y squared. Plus a function of x. Now we have two different descriptions of f. Let's harmonize it. What function will satisfy both descriptions? Well, they do have 3 over 2 x squared cosine y. In other words, if you are an investigator trying to figure out the real criminal, you go around interviewing people and they give different description of the same thing, right? Both people say that it should have this, so I can confidently put that in there. But then one says, oh, it's 5x and some function of y, I don't know. And here it says, oh, that function of y must be y cubed. So I can say, hey, that must be this y cubed that we're talking about. And then looking at this description, it should be the same as that one. So I put that as 5x. And then you see that this agrees with both of the description of the f. So we're good. Okay?
Equals a constant.
Equals the constant, and that's put it as a constant. And this is the solution to this, the differential equation.